Hello everyone, welcome to OVERMUGGED Sec 3 IP Chemistry End of Year Revision. Today, I'm Miss Felicia. So today I'll be guiding you all through these three concepts: ionic equation, salts, and the mole concept. So just to give you a heads up on the lesson plan for today. So for the lesson today, I will start off with the notes for ionic equation, then salts, then I'll do a Kahoot on these two topics. Yeah, so in the Kahoot, for the top winner, that means only the first position of the Kahoot quiz, the winner will get to win away the end of year revision exam kit. So stay tuned. And then for those of you who are not tested on the mole concept for this Sec 3 end of year chem exam, after the Kahoot, you can choose to leave already. So for the worksheet today, I will be providing the answer key for today's worksheet at the end of the lesson. So for those of you who need to leave earlier because you are not tested on mole concept, you can actually just follow the OVERMUGGED O-level Telegram chat. In there, they will actually post the recording. So you can just look at the recording. There is a description because it's a YouTube video. So you can look at the description in the YouTube video for the answer key. So for my lesson, I will require you to at least print out a copy or download a copy because you will be required to highlight and write in it. So I will need you all to follow me closely. That means whenever I highlight or I write anything, you should also follow and highlight and write in it. Okay, so let's begin. Okay, for ionic equation. So just to let you know that for today's topic, I am not going to teach you the entire chapter. So I'm only going to focus on selected section. So like for example, chemical equation, I'm not going to go through chemical equation from the start, but I'm only focusing on ionic equation. So same for salts also. I won't teach the entire chapter, but I will just focus in helping you to find out, like if there is this question, then do you know like which method to choose? Is it like titration or precipitation or what method? So today's lesson is more of like focus on selected concepts in that chapter, but not the entire chapter. Okay, so for ionic equations, take note that when you write it, it is a must to have state symbols because state symbols is the one that help you to like derive what the answer is. And whenever you write an ionic equation, take note that the ratio of the ions should always be in the simplest form. Meaning like, for example, like chemical equation, you don't write like maybe 2 of the substance plus 4 of this substance to get 2 of this substance, right? Because 2, 4, 2, usually for chemical equation, we will change it to 1, 2, and 1. So same for ionic equation also. If can simplify, you always simplify to the lowest ratio. Okay, then next is that for ionic equation then got charge. So that means chemical equation, right, usually don't have the plus minus charge sign. Okay, so only ionic equation got charges. And next is for ionic equation, you can actually differentiate them into 3 different types. So for the first method, which is neutralization reaction, there will be a shortcut. Precipitation also got shortcut. Then for displacement reaction and all other reaction, it will be the one that you normally learn, which is write out all the ions, then you cancel away the spectator ions. So only the third one, you really need to like do it the long way, cancelling spectator ions. But for the first 2 methods, there is a shortcut, which I'll be sharing it with you. Okay, so I take it that all of you should be done highlighting by now, right? Because there's only like these few things to highlight. So I shall move on. If you are not done, you want to maybe take a screenshot because I'm going to move on in 5 seconds. 5, 4, 3, 2, 1. Okay, moving off. Okay, so let's begin with the first reaction, which is neutralization reaction. So for neutralization reaction over here, I'm looking at specifically the chemical reaction between acid and alkali. So for alkali over here, take note that the base over here I'm referring to, it must be the soluble one. Okay, so maybe I should be a little bit more specific. Alkali. So for soluble base, which is alkali, and acid, whenever both are in the aqueous form, take note that the ionic equation is definitely this. So that means no matter what acid and alkali you use, the answer will always be the same. That's why once you realize that it's an ionic equation, it's like you can shortcut and get the answer. Don't need to write out the entire like equation, then cancel out spectator ion. Don't need. Because even after you cancel out the spectator ion, you will still get back the same answer. Okay, so let's give it a try. Okay, so for the first question over here, they are asking you to write the ionic equation for the neutralization reaction between dilute sulfuric acid and dilute sodium chloride. So you see, as long as both of them are aqueous, because I said that it must be soluble, that means the answer will be the same. So that's why the answer you just need to copy from the top will do, which is H for acid, OH minus for alkali. So neutralization, that's why you form the neutral water. So this will be the answer. So can you just copy this equation in? Yeah, just copy this equation in. So this will be the answer. And so for neutralization, it's very straightforward. Can do it very fast. Okay, so moving on to question number 2, they said that to write the ionic equation, so this time around, they are very nice. They tell you that it's neutralization reaction between dilute, dilute means aqueous, right? And then dilute also aqueous. Or you can use the solubility table. So if you have memorized the solubility table, then you will know that nitric acid and calcium hydroxide are aqueous. So the answer will be the same again. So can you now copy this same equation into the answer for question number 2? Yeah, so this will be the answer for question number 2. Yeah, copy in. Yeah, this one. Remember to include the state symbols too. Should be done copying by now, right? For question number 2. Okay, so let's move on. Okay, so done for neutralization. Very straightforward. Next, for precipitation reaction. So for precipitation reaction, there is also a shortcut. You don't need to write out the spectator ions. So what you need to do first is you need to be able to at least tell that this is a precipitation reaction. So how do you tell that it is a precipitation reaction? You look at the state symbols again, because ionic equation always need to have state symbols, right? So you check the state symbols. As long as for the chemical equation is like that, that means aqueous, aqueous, you get solid aqueous. So it's like 2 liquid you mix together, suddenly got precipitate forming. That's why this solid is the precipitate. That's why it is a precipitation reaction. So for precipitation reaction, what you do is you go and find out who is the solid first. So once you found the solid, you write its chemical formula over here. Then next is what makes up this precipitate. It will be 2 things. So that's why you just write down the first thing plus the second thing, you will get this. Okay, so that's why what I've just mentioned to you is over here. You start off with writing what is the insoluble product first. That means your precipitate. Then you work backwards. So for example, if this is like calcium sulfate, then you just write down calcium sulfate is actually Ca2 plus SO42 minus. Done. So that means you just write out what forms this precipitate. Yeah, that's what I'm trying to say is that solve for the reactants, and then remember to include the coefficient. That means like if there is a need to put any number in front, then maybe if your chemical formula is like SO4 then bracket 2, and then must remember to say that it's 2 SO42 minus, like you must remember to put the number 2 in front, because for ionic equation there is still a need to balance the equation. Okay, so what am I trying to say? If you're not sure what I'm trying to say, let's directly look at an example, then you can better understand what I'm trying to explain. Done highlighting, right? I shall move on in 5 seconds. 5, 4, 3, 2, 1. Okay, let's move on. Okay, so let's take a look at this question over here. So they are asking you to write the ionic equation for the precipitation reaction between copper 1 nitrate and potassium carbonate. Yeah, so first is you have to deduce what is the salt. Yeah, so in this case for precipitation is usually like you just change the partnering. That means the first one partner with the second one, and then the second one partner with the first one. That's why for the first combination, which is copper with carbonate, yeah, then the second combination will be potassium with nitrate. So once you have exchange partner for these 2 salts, you need to base on your memorizing of the solubility table. Yeah, so for these 2, which one is the solid one? Yeah, so based on solubility table, copper 1 carbonate is insoluble. So this is the solid. So you write copper 1 carbonate formula over here. Yeah, so for copper 1 carbonate, just a reminder, whenever you have metal, remember to do the crossing. That means like Cu plus and CO3 2 minus, remember to do this crossing. Okay? Yeah, so that's why it's times 1, and then this side is times 2. That's why you get Cu2, CO3. So for precipitation reaction, don't need to write out spectator ions. You directly write what is the solid precipitate over here. Then after you're done writing already, next is what makes up copper carbonate. It will be copper and carbonate that makes up copper carbonate. Yeah, so that's why you write down the chemical formula of the copper ion and the carbonate ion. Then remember to include the front number to balance the equation. Yeah, because you have total 2 copper, so remember to put it in front to balance the equation. Yeah, so can you highlight this number 2? Yeah, so don't forget this, okay? Must make sure that the equation is balanced. Done. So it's very fast, right? You just write the product, then what makes it up? Copper and carbonate. Then include state symbols, balance the equation, done. Okay, so now your turn. So there are 2 questions at the bottom. Can you all finish them now? Then once you are done, I will go through the answer. So take note, okay? Use this shortcut method, okay? Don't go and write out the spectator ions. Yeah, because exam time is precious. Yeah, so finish up the class practice now, the 2 questions. Then once you have finished the class practice, can you click the raise hand button to let me know? So once majority of you have finished, then I'll go through the answer. Yeah, so raise hand when done. By the way, for those who came in late, you are required to print out a copy of this worksheet, which was actually emailed to you. So if until now you still don't have this copy of the notes, can you let me know now so that I can send you the link for this worksheet? Okay, so if you don't have this worksheet, let me know. Reminder again, once you have finished the 2 questions for under precipitation section, that means the class practice here, the 2 questions will do. Once you finish, click the raise hand button to let me know. If you're unable to click the raise hand button, you can type the word done in the chat to let me know. Okay, I think I shall go through the answer now since more than half of you all are done. Okay, so here comes the answer. Yep, so this is the answer. So for lead nitrate and ammonium chloride, you either form lead chloride or ammonium nitrate. So for SPAN, ammonium and nitrate, they are soluble. So that's why the precipitate will be lead chloride. Then do you remember to balance the equation? Do you put the number 2 in front? Yeah, if didn't, can you do as correction? Yeah, so don't careless, okay? Yeah, so it's very straightforward. Lead chloride is made up of lead and chloride. Take note, the front 2 are always aqueous because for precipitation, I mentioned to you, it's always aqueous, then over here get solid aqueous. Okay, so the starting must always be aqueous. This is the next answer. You can see, let me make it even bigger. Yeah. So this is the answer. So same thing, you just swap the partner around. Calcium sulfate versus iron hydroxide. Yep, so for calcium sulfate, yeah, it will be the precipitate. Done. Okay, right. Okay, so I shall move on. Okay, so continue on to the next equation, next section. It will be the displacement reaction. So whenever you can't solve, right, you have to do the usual way, which is the write out spectator ions kind. Yep, so yeah, for displacement reaction, it will be the more reactive metal will displace the less reactive metal. Yep, so this only if you have learned the topic of metals, which I believe most of y'all are only learning it next year. So I'm actually putting it here so that it will still be relevant for y'all when y'all learn Sec 4 chemistry. Yep, so generally a metal that's more reactive, he will kick out the one that is less reactive. So iron will now be alone. For part 2 over here, another way is it can be group 7 element, yeah, or group 17. Yeah, so for group 7 or 17 for halogen, generally also same thing, the more reactive one can kick away the less reactive one. So this one, it will be covered in the topic called periodic table. Okay, so if you haven't learned periodic table, you will learn it soon in Sec 4. So same thing again. So for displacement reaction, is always the more reactive one, always kick away the less reactive one. So how to understand it? It will be, you can actually base on maybe, I let all the metals to maybe be the male. Okay, something like that. Yep, then I let all the non-metals to be the female. So what you do is that, okay, so female wear skirt. Okay, so in this case, you take it that if aluminium is more reactive, okay, so now I'm telling you that the fact is aluminium is more reactive than iron. So if aluminium is more reactive, that means you take it as aluminium is like the more proactive guy. So more reactive is like more proactive. As compared to this iron guy who is like less reactive, which is less proactive. So imagine if this aluminium guy is so proactive, or keep texting this girl, keep trying to like bump into her in school, try to like ask her out. So very proactive. But then for her original boyfriend, can you see that the two of them are like attached together? Yeah, so if this boyfriend over here is like so not proactive, whole day like just stay at home kind, very introvert kind, yeah, don't really text a girl kind. So after a while, since this guy was so nice, keep giving her flowers, chocolate and all, after a while, this girl will get together with this guy, right? That's why aluminium got together with sulfate, as shown over here. Then this guy said, yeah, he will end up being alone. Okay, then for halogen, likewise also is about the more reactive one displaced the less reactive one. So now same thing, I stick to the same case where the non-metals are the female. So fluorine is non-metal, bromine also non-metal, sodium is metal. So metal will be the guy. Yep, so in this case, same thing. If I were to give you the heads up information that, for example, after you learn the topic of periodic table, if fluorine is more reactive than bromine, that means fluorine will kick away bromine. Yeah, so if fluorine kick away bromine, that's why in the end, fluorine can get together with sodium, because if she's more proactive, will keep on text the guy, talk to the guy, try to like meet up with the guy, give him gift and all, as compared to the original girlfriend who is like less reactive, less proactive, like didn't really like talk to the boyfriend. So after a while, this girl will get together with this guy, right? That's why you see, in the end, it will be sodium will be together with fluorine. Yeah, so this is called displacement reaction. So bromine get kicked out and bromine will be alone. So for displacement reaction, as well as all other kind of chemical reaction, the method to do for ionic equation is what you have already learned in school before, which is first you have to write out the balanced chemical equation with state symbols, because yeah, you need state symbols to deduce the ionic equation. Then you have to rewrite the chemical equation into ions. But take note, only aqueous substances can then become ions. So that means for solid, liquid, gas, cannot become ion. So you see over here, see when it's aqueous, it become ions. But if it's solid, you just copy the same. So solid, liquid, gas, you cannot change it. It must be exactly the same. Only aqueous, you then break them apart. Okay, so that is the second step. Then third step, you cancel the spectator ions. So take note that for spectator ions, it is the ones that is exactly the same. That means be it the state symbols, the charge, it must be exactly the same. Yep, so if you were to compare left versus right, only the nitrate is exactly the same, right? In terms of charge and the state symbols. Yeah, so the only one you can cancel is nitrate. Because like for silver, you see it's different. The state symbol and the charge. Over here, no charge, different state symbol. Yeah, then for zinc is also different. So you cannot cancel them. So for spectator ions, they are the ions that is exactly the same. Yep, so only those that is exactly the same, then you can cancel them. Then finally, what's the final answer for the ionic equation? You just copy down the remaining. Done. So that will be the answer. Then lastly is do a quick check after you have completed it. Yeah, check is the equation balanced? Yeah, because be it chemical equation or ionic equation, as long as it's equation, it must always be balanced. Okay, so I shall move on since I didn't really write much over here. Okay, so let's take a look at over here, this question here. Yep, so if you need some space to try out, you can use the space below to like write out your equation, then you cancel the spectator ions. So I will give you some time now to complete them. Can you do it now? Yep, so you complete these two questions. Then likewise, after you are done, click the raise hand button to let me know. Just these two questions will do. By the way, just to let those of you who are fast, like some of you already raised hand, right? Just to let you know that I also provided extra practices here. If you want to do more practice, you can actually finish the question up. Then at the end of the lesson, when I give the answer key, you can check your answer. Yeah, so while waiting, you want to like maybe complete them first. But for the rest of you, once you have finished just these two questions, can you raise hand to let me know so that I can go through the answer? Yeah, just these two questions. Once you are done, raise hand. Just to check, like Beverly, Cal, Shanice, Tian Hong, and ZL, and a person whose name is full stop. Like, are you all done? Are you all still doing? No response. Is it like not present here? Okay, then maybe in that case, I think I shall go through the answer because majority is done. Okay, come, let's check through your answers. Yep, so here's the answer over here. Yep, can you check your answers? Okay, any of you need me to demo to you how to get the ionic equation for question number 1 or 2? Need me to show you the working? If you need, you make sure you say, if not, I take it that you can get it correct, then I move on. If you need, you tell me now, I will demo to you. Okay, so since no one said anything, that means I take it that both of them, you all got it correct. Okay, sure. Question number 2, I'll go through. So those who don't need question number 2, you can just continue to do the homework questions below. Yep, while I go through question number 2. Okay, so for question number 2 over here, let me scroll up a bit so that I got more space. Okay, so for question number 2, they said that write the ionic equation for dilute nitric acid. So by right, you need to memorize chemical formula for nitric acid is HNO3 and potassium carbonate. So potassium carbonate, since got metal, whenever got metal, you need to do the cross product. So K plus and CO3 2 minus, you cross. So this will be times 2 and times 1. So that means it's K2CO3. Then need to remember that SPAN, P for potassium, SPAN, they are all soluble. So potassium is soluble because potassium is P. Then next is acid plus carbonate. So this is what you learned before in the topic of acid bases, right? Even Sec 2 also learned before, right? So acid plus carbonate, what do you get? So there is actually a mnemonic called CASH. So carbonate and acid, you can get salt and H2O, and carbonate confirm got carbon dioxide. That's why it's CO2. Oh yeah, sorry. Oops, thanks for highlighting. Oh yeah, I write wrongly. Oops. People, can you all double check? This one must be gas. Thanks for highlighting. Thanks, Rennie. Yep, so this should be gas. Yep, so acid plus carbonate. So Ca, you get SH. Maybe I write H2O first, since it's easier. And carbonate, sure got carbon dioxide. Yep, so what is my S? My S is the salt. So the salt, it will be the leftovers, which will be potassium and nitrate. Yep, then next is all of them must have state symbols. Yep, so gas is G, this is aqueous. Okay, then next is only aqueous, you then break it into ions. Oh, sure. The SPAN. Okay, so usually how to memorize solubility table is that you go by SPAN, S for sodium, P for potassium, A for ammonium, N for nitrate. As long as it's SPAN, they will all be soluble. That means the state symbol, it will be definitely aqueous. Yeah, so I actually have quite some mnemonics that I usually teach during tuition to help you all remember solubility table. Another one is the carbonate, the sulfates. Yeah, so for sulfates also got this kind of mnemonics to help remember. So sulfates, it will be S for sulfates. Sulfates are S for soluble, except the 3 sizes. Yeah, so only the 3 signs which you learn, it will be chem, bio, physics, correct? So only these 3 are insoluble. So chem biophysics refers to calcium, barium, and lead. Yeah, so only these 3 are insoluble, bracket solid state. The rest are always aqueous state for sulfates. Yep. Okay, then so for this question over here, because potassium, P for potassium is soluble, and then nitrate is N is soluble, that's why the state symbol is aqueous. So in this case, now you break all the aqueous into ions. So acid, you know, right? It always forms H plus ions to give it its acidic property. Then NO3 must memorize NO3 minus. Since this one is also aqueous, means you need to break it into ions too. Then and CO3 2 minus aqueous. So as long as aqueous, you must always break them into ions. But this kind, liquid and gas, you cannot break to ion. Because solid, liquid, gas, you just copy directly. Just copy exactly the same. So you see, I never modify it at all. I just copy water and carbon dioxide. And then over here, aqueous again. Then you need to break it into ions again. So it's K plus aqueous and NO3 minus aqueous. Okay? Yep. So then in this case, check which are the ones that look exactly the same. It will be nitrate, because you see it's NO3 minus aqueous. Over here also same. So you cancel. Then next one, K, also exactly the same, right? You cancel. The rest are different already. So then you just copy down the remaining, then that will be the answer. Oh, wait, sorry, I forget to balance the equation. Oops, sorry. I must be more careful in the exam, okay? Yep, so to balance the equation is K2, so must be 2K. That's why 2 nitrate, then 2 nitrate. Yep, so this is the equation. So when you have the number 2, must remember to transfer it into your equation also. Yep, so over here 2K and 2NO3. That's what I mean by remember to put the number in front. Yep, so then you just copy down the remaining. That will be your ionic equation answer. So it's 2H plus aqueous, CO3 2 minus aqueous, CO2 gas, and H2O liquid. Yeah, so we just copy down the rest. Will do. Okay? Yeah, done. Okay, so I take it that this question is asked by, hold on. M, so M, you understand what's going on now? Can follow? No response from M. I don't know what's going on. Can I? Okay, good. Thanks. Okay, so then next is ZL is asking about chlorine in question number 1. Wait, where's my chlorine? Over here. Why is it aqueous and not gas? Oh, because only when, oh, this one is, hey, wait, let me see. Oh yeah, sorry. Oops, careless again. Sorry. Typo. Yeah, this one should be gas. Yeah, because I mentioned it's a gas. Yeah, good point. Thanks. Yep. So can everyone take note, like, do you all write as gas? I hope it should be correct, right? Yeah, because they said gas. Yeah, sorry, typo. Okay, so I shall move on. Anyways, for those of you who are super fast, if you have already completed the below part, you want maybe do a quick check through of your below answer. Let me shrink it so that I can fit all 4 questions. But no worries, okay? For those of you who haven't finished it, I will be providing the answer key. Yeah, so don't busy copy down. You give it a try first. Then later you do ready, then you check with the answer key. Okay, so this is more for those who are fast. If you are done, you can just check through your answer. I'll give you a bit of time, then I'll move on to salts. Then if any of you got any of it wrong, you try to figure out, see whether you know how to deduce the answer. If you do not know why your answer is like that, you can stay back after class, then I can go through with you on how to solve like any of the equations here. I take it that you all should be done checking, right? Because it's just 4 answers. Should be done by now. So I shall move on in 5 seconds, okay? If you want to take a screenshot, you can, but I will send the answer keys still, so no worries. Okay, so I'm moving on in 5 seconds. 5, 4, 3, 2, 1. Okay, moving on. Okay, so now to the next section on salts. So as mentioned, I won't teach the entire chapter. Yeah, so I'll only focus on the difficult parts. Yep, so for the topic of salts, you all know that there are mainly 3 types of chemical reaction, right? The titration, precipitation, add excess insoluble to acid. Yeah, so usually if a question, for example, they say, I give you calcium sulfate. Can you tell me out of these 3 methods, which one to choose? Or maybe I give you another one, maybe potassium nitrate. And then out of these 3 methods, do you know which one to choose? So that is what I'll be teaching you. How to decide out of the 3 methods, which one to choose. Okay, so how you remember is, I don't like the flowchart in the notes. Because usually the notes or textbook, the flowchart, very hard to remember. Yeah, so for me, is the way I remember is I go by this. I go by whether is it SPA or non-SPA. So SPA over here refers to sodium, potassium, ammonium, okay? Sodium, potassium, ammonium. So if you look at the chemical formula of the salt, so maybe I say I want to prepare maybe potassium nitrate. So if it's potassium nitrate, it will be the left side over here. Okay, yep, so then it will be spa salt. That means you should use titration method. But if it's not spa salt, like example, if I say calcium sulfate, for example. So if I say calcium sulfate is not spa, then next is you check the solubility table. Are they soluble or not? So for calcium sulfate, by right, need to memorize. I told you, right? All sulfates are soluble except the 3 sizes. Yep, so it will be the 3 sizes are biochem physics. Yep, so this time around the chem is calcium lah. So that's why it will be insoluble. Yep, so in this case, it will be insoluble. That's why you use precipitation. For the last example here, it will be maybe I say I prepare iron sulfate. So all sulfates are soluble, right? And iron sulfate, iron is not SPA. That's why iron sulfate is soluble. You use this method. Okay? So for this table, just to let you know, it's a very flexible table. You don't need to like memorize. Okay, first row is salt, second row is spa and non-spa. Even if you mix them around, like you thought that the second row is soluble, insoluble, also can. It will still work. Let me demo it to you. So that means, for example, if you didn't memorize exactly the same, I memorize as soluble and insoluble, can also. So as long as it's insoluble, you will immediately choose precipitation. Because remember, precipitation, just now I went through with you in Ionic equation, precipitation is you form precipitate solid. Yeah, so if you form solid, the salt is solid, that means it will be insoluble. That's why it's the precipitation method. Yep, then as compared to soluble, it will be, you then write the spa and non-spa. Yeah, so you can actually rearrange them. So for soluble, spa, it will definitely be titration, because as long as it is spa, remember just like I told you, SPAN, they are always soluble. So SPA, since confirmed soluble, you do titration, because in titration, it will be the acid and alkali in the burette and pipette, right? You realize they are all like liquid form. That means they are all soluble. Then even after you finish the titration in the conical flask, it is still liquid form, right? That means it's also still soluble. That's why at the start or at the end, forever soluble, you choose spa, because spa confirm always soluble. Yeah, that's why titration, it should be spa. Then non-spa, it will be the last one, which is the add excess insoluble to acid. Okay, then next thing to take note is that actually titration and add excess insoluble to acid is pretty similar. Okay, so by the way, sorry, I go backtrack a bit. So can you all tell that you see this flow chart and this flow chart will get the same result? Because if I go by this insoluble precipitate, you look over here, salts, they're insoluble. There's only one insoluble, right? Because spa confirm soluble. So insoluble confirm is precipitation. Then for soluble, spa, titration. Then spa, titration. Soluble, non-spa. Soluble, non-spa. It will be add excess. Add excess. Can, so actually the flow chart is the same. So you just use either one. It doesn't matter. There's no fixed rule for this flow chart, for the sequence. Okay. Okay, so then next, just now I was saying that titration and add excess insoluble to acid is pretty similar. The reason is because these two are actually just what you learn in the topic of acid bases. Yeah, so in the topic of acid bases, even in lower sec, you studied that there are the standard 3 equation, right, which is like metal plus acid. So metal plus acid, what do you form? To remember, I will have this mnemonic. Yeah, so usually my lesson a lot of like techniques to help you to study. Yep, to remember also. So it will be called mesh. So metal plus acid, you form salt and H2 gas. Okay. Then the second one is called bash, BASH. That means base plus acid, you form salt and H2O. So the H sometimes is H2, sometimes it's H2O. I have to be careful. Then the third one I already showed you, right, is the cash of CaSH. Yep, so carbonate plus acid, C and A, form salt and water, which is H2O, plus, remember, carbonate always form carbon dioxide. Yep, then plus carbon dioxide. Yep, so that's how you can remember the equation. So for these two, it is all the acid-bases equation. Because you see, even here, same thing also. Acid plus alkali. Alkali is base, right? Then carbonate is this. But I only missing metal because there isn't any metal that is soluble. That's why I can't put over here. So key point in titration is it must be soluble. So that's why I write down all the acid reactions that are soluble. So I write acid and alkali, acid and carbonate. So those that are insoluble, you put here. So you see, it's all the acid equations, metal, then you choose insoluble. As compared to the left side, it is soluble. Same for here, the carbonate is insoluble, while titration, it will be soluble. Okay, so these two are the same acid-bases equation, just that titration is soluble, this one is insoluble. That's why the title says insoluble. Okay, so take note that you add excess of the insoluble one, you don't add excess of the acid, okay? The reason is because, why cannot the other way around? Why cannot add excess acid to the insoluble stuff? Is because the insoluble stuff is easy for you to remove. Because you see, over here, all of them, in the end, they will form salt, right? Because acid-base equation should have salt. And for this side, the salt, you look backwards, they say it is soluble. That means all the salt here is aqueous form. That means they are all like, like liquid version. Yeah, so if you go and add excess acid, acid is also aqueous, right? If you have two things that is aqueous, that means I add excess acid, which is aqueous, and then my salt also aqueous. Then how can I get my pure salt? My salt will be like acidified, right? Yeah, there will be acid impurities. That's why you cannot excess acid. It should be excess insoluble instead. Because for insoluble, it's easy to remove. Because example, I just do filtration, will do. Yeah, so for filtration, my excess insoluble, which is like the metal, it will get stuck on top. Yeah, so the metals will be stuck on top, while my filtrate, it will be, because my acid is used up, right? I excess metal. Excess metal means acid gone. So that means I will be only left with my salt. So that means over here, it will be your salt, which is good because my salt is pure now. Yeah, don't have impurities. Yeah, so that's why take note, okay, it's excess insoluble because it will be easier for you to remove the solid. As compared to two liquid, it's very hard to remove. That's why don't excess the acid, which is aqueous. Clear? Okay, so this is how you identify which method to choose. After you identify the method, usually the question will ask you like outline the procedure. Yep, so take note that usually after titration, because you are having a conical flask of like liquid stuff, you need to do crystallization. Usually we tend not to do evaporation to dryness because evaporation to dryness is, the product is impure. For crystallization, it will be higher purity of your product. Yeah, that's why usually we choose crystallization even though it's lower. Okay, so crystallization, take note, crystallization gets a more pure product than evaporation to dryness. Okay, then next, for precipitation, how do I obtain the salt? So the salt is the insoluble salt, right? This is my salt. So how do I obtain this salt? It will be solid separate from the rest, which is aqueous. So you do filtration, then you can obtain the solid. Next one over here. So for the salt is aqueous. So aqueous, so same thing, as long as aqueous salt, you must always do crystallization. That's why the next step is crystallization. Done, that's all. Okay, so I hope you have noted down all these things that I've been writing. So I'm going to move on in 5 seconds. If you are left with a little bit, you want to quickly note it down. If you are left with like a lot, you want to take a screenshot. Okay, so moving on in 5 seconds. 5, 4, 3, 2, 1. Okay, moving on. By the way, anyone got any questions so far? So, all okay? Okay, so then next is over here. When you do the experiment, do you need to measure accurately or not? Only titration you need. This one you know, right? You all did the experiment in school. Okay, for precipitation, don't need. You just randomly take 2 beakers of aqueous solution, just anyhow mix. Will do. Yeah, because the salt that you want, it will be the solid, which you can obtain via filtration. So anything that is in excess, it will be together with this aqueous stuff to be thrown away. Yeah, so this one don't need accuracy. For this method over here, also don't need accuracy. Oh yeah, by the way, forget to mention, you need filtration to remove the excess insoluble stuff. Yeah, then your soluble salt, then do crystallization. Okay, so for this method, also don't need accuracy because you already say excess, that means you never measure the exact amount for reaction. You're already adding in excess. So excess, that's why, yeah, it's not accurate. Okay. So over here, this is the solubility table. So as mentioned just now, mnemonics to help you remember will be SPAN. So all span are soluble, that means aqueous. Sulfates also got mnemonics, right? Sulfates, I don't want to write anymore. The one you all should know, which is the S for sulfate, S for soluble, except the 3 sciences. Okay, so the 3 sciences are here. Physics, bio, chem. Okay, so except the sciences. Okay, I end up still writing. Okay, so then BCP. Yep, so then for carbonates, also easy to remember because carbonates is same as on top, which is span. So carbonates is, yeah, only the spa carbonates are soluble, then the rest will be insoluble. If you notice, I never include N because N is negative. Carbonate also negative. You don't have a chemical formula that have 2 negative because both with the same charge, both negative will repel. Just like magnets, if both are north pole, they will repel. That's why cannot have nitrate and carbonate together. So I just choose the positive ones, which is S, P, and A. Then hydroxide also similar, but add 1 more letter C. So it's just SPCA. Yeah, like the Animal Shelter Organization. Then the only one that need to memorize by heart, it will be chlorides. Like chlorides, I don't really have a mnemonic, but chloride is still quite easy because only got 2 of them. Yeah. Okay, yep, so you need to use this table to help you to deduce which method, because need to check whether are they soluble or insoluble. Okay, so now let's take a look at this commonly tested question. This one, right, if can you go and memorize the answer? Because this kind of question keep coming out. It's very, very often tested. Yeah, maybe you might have even done this kind of question before in your school worksheet too. Okay, so if they were to say that this time around they want to prepare CaSO4, but they say they use this method. Okay, so maybe first let's decide on our own without being influenced by the question. If it's CaSO4, which method should I choose? So now let's take a look at the flow chart. So for CaSO4, so first, CaSO4, is that letter SPA or not? So CaSO4 don't have, right? CaSO4 don't have sodium, potassium, or ammonium. So CaSO4 will be on the side. Then next, you check solubility table. CaSO4, is it soluble or insoluble? So CaSO4 is over here. It is insoluble, okay? So if it's insoluble, you should go to the left side. So it should be the precipitation method. Okay, come, let's write it down. So by right for CaSO4, it should be the precipitation method. Okay, this is the correct method to do. But now, the question trying to be funny. They don't want to use precipitation method. They want to add excess insoluble to acid method instead. Yeah, so they purposely use a wrong method. So can or not? The answer is can. You want to use the wrong method, still can. Just that it is not ideal. So not ideal in terms of what? Not ideal in terms of the yield of the salt that you get. That means at the end of the reaction, the amount of salt that you will receive is much lesser as compared to the correct method of precipitation. So let me show it to you. So for example, this question is asking you, explain why this method is not suitable to get this CaSO4 salt. So in a way, this method still works is because they are getting insoluble carbonate like CaCO3, right? In this case, plus acid H2SO4. So yeah, there is really such a reaction happening, right? Because you learned it before in the topic of acid bases, the equation CaSH. Yep, you get the salt and water, and carbonate sure get carbon dioxide. So in this case, do you realize, yes, I still get my CaSO4 salt. So why cannot use this method? The reason is because CaSO4, you check the solubility table, it is solid state. So if CaSO4 is insoluble, so example, I have this CaCO3 surrounded with the acid. So usually when the acid molecules react, they react with the surface of your CaSO4, correct? So if your acid react with the surface of the CaSO4, sorry, I read wrong. It should be CaCO3. Sorry, this my powder here is CaCO3. Yep. So if my acid were to react with the CaCO3 over here, after a while, you will form this CaSO4, right? So this CaSO4 will end up forming a layer around this substance because CaSO4 is insoluble. Because usually when you react, you always react with the outside ma. You can't possibly react with the inside, right? So if you react with the outside and then the product form is solid, it means you will form an insoluble layer around this CaCO3. Yep, so that's why in this case, after a while, if they form this like layer, then the acid cannot react with the newer CaCO3 that is inside. Yeah, so that's why you won't be able to continue to have the reaction. So the reaction, once your insoluble layer is formed, then you cannot have any more reaction because the other calcium carbonate is not exposed anymore. That's why lower yield of salt is obtained. That's why not recommended to use the wrong method. Okay, so although yeah, you can get, but the yield is low. Okay, then another reason is because both CaSO4, which is the salt that we want, yeah, because they are asking you to prepare CaSO4, right? As well as this carbonate, yeah, the insoluble carbonate, which is this CaCO3, they are both insoluble. So if you have two of them that is solid, how do you separate them? Yeah, because even in the topic of separation techniques, you also don't learn like two solid separation ma. Yeah, so it's very difficult to separate two solid things. And someone is like wrap one layer around it. Then like, how? Yeah, how to obtain? Yeah, so how do you obtain only the outside layer without like, you know, accidentally scraping the inside layer of the calcium carbonate? Yeah, so it's very hard for you to separate them. That's why it's not recommended for you to use this wrong method law. Yeah, so that's why for insoluble product, as mentioned, you are supposed to use the precipitation method. Yeah. Yeah. Done. Okay, I take it that you should be done highlighting by now, as I mentioned. Okay, so I'm going to move on in 5 seconds. If you are not done, maybe you want to quickly highlight or you screenshot it if you can finish it in 5 seconds. Okay, so moving on in 5 seconds. 5, 4, 3, 2, 1. Okay, moving on. Okay, so now let's train you to see whether are you able to tell which method to use out of the 3 methods. Okay, so let me demo maybe the first 2 for you, then the rest you do it on your own. Okay, so for example, the first one over here, they say that you want to produce lead 2 chloride. So same thing, first thing, always check the solubility and the flow chart. Okay, so let's check lead 2 chloride. So based on this solubility table here, lead 2 chloride is insoluble. So if it's insoluble, you follow the flow chart. So lead and chloride, they are not spar and they are insoluble. So that's why the answer will be precipitation method. Okay. So since my worksheet says that you are supposed to take all the steps, take all the methods, so you should write precipitation and filtration. Okay, so let's write that in. So this one will be precipitation and filtration. Yeah, follow me and copy it down. Okay, then next, we need to decide what's the reactant. So same thing, follow back the flow chart. So for precipitation method, you should add starting reagent both to be aqueous. So now let's take a look. So over here, yes, the first one is already aqueous. So my second answer must also be aqueous. So since I need to get lead chloride, so chloride is settled, right? Because the chloride is here. That means now I'm only left with lead. So that means over here, I must have lead. So can you choose lead something such that it is aqueous? So my recommendation will be always choose SPAN because SPAN is always aqueous. So this lead, the possible answer will be nitrate law. Yeah, because lead and nitrate, one is cation, one is anion. Then remember, do the cross product. So after you do the cross product, it will be bracket 2. So this will be the answer. Okay. I demo one more to you, then the third one onwards you do on your own. So next one, copper 2 nitrate. So copper 2 nitrate, which method to choose? So same thing, you follow the flow chart. So for copper 2 nitrate, first, copper, is it SP or A? No, right? Copper is C. So that's why not SPA. Then copper 2 nitrate, SPAN. N is always soluble. So that means it will be non-SPA and then soluble. So that means the method will be add excess insoluble, one of them, to acid. Okay, then also must copy filtration and crystallization. Okay, so let's write these 3 in. Okay, so it will be add, oops, wait, hold on, let me scroll properly. Okay, yeah. So first we say add excess insoluble. So we need to identify which one is it. So you can choose, do you want to choose the metal or the base or the carbonate to the acid? So this time around, they specify the acid is nitric acid. So you have to write nitric acid. Then continue to copy down the list. The next arrow was filtration, right? And then the next arrow is crystallization. Okay, so now I have a question for you. So over here for the blank, right? Based on the acid bases reaction is acid plus metal, acid plus base, acid plus carbonate, correct? But then there's one answer that cannot be filled in for this particular example. Only this example. Anyone able to tell me which one is it? Very good. Yep, Ethan. Yeah, you cannot add copper. Okay. Yep. So this time around, yeah, metal has to be eliminated because you need to remember that copper is an unreactive metal. So unreactive metal don't react. Okay. So much remember. Yeah, so this time around, you cannot add pure copper because it's unreactive. Yeah. So this time around, you can add base or carbonate. So base is always metal oxide or metal hydroxide. Yeah. So you can either write copper oxide or copper hydroxide, or you want to write copper carbonate, also can. So that means over here for this blank over here, you can either write copper oxide, this is copper 2 oxide, right? Then CuO, or you want to write copper hydroxide, also can, or you want to write copper carbonate, also can. So these are the 3 acceptable answers. Okay, then next is what blank do you fill in over here? So since we say it's excess, the method was acid plus excess insoluble, right? So it's insoluble stuff. So it should be insoluble this. So it's not any random insoluble stuff. Yeah, you cannot like anyhow say what copper, some other insoluble stuff, cannot. It must be really base or carbonate strictly. Okay? Yeah, but sometimes can be metal lah. Yeah, so that means this time around, the answer will be either one of them. You want to write CuO also can. You want to write Cu bracket OH2 also can. Or you want to be CuCO3 also can. Okay? So take note, it must be always acid plus metal, base, or carbonate. It's not any random stuff. Yep, like that. Okay, so after you are done copying, can you finish up this whole table? Then likewise, after you are done with the whole table, click the raise hand button to let me know. Then I'll go through the answer. I'll recommend that you check through the answer first, because I know on the next page, I have another page of homework, but just in case, like if you concept error over here, then if you do the next page homework already, right, before I go through, I scared you might error carried forward. Yeah, so best is don't do the homework first. You check through first. Yeah, check through your answer first before you do the homework. Oh yeah, I just saw Ethan's message. So Ethan is asking about the on top question, right? You are saying, why is it, Ethan, are you asking for this question, or are you asking about like maybe an example that I went through in front? This example, okay. So you're asking, why can't we add HCl to CaCO3 and CaSO4 so that CaCO3 is reacted away to form CaCl2, soluble salt, CO2, and H2O? Wait, let me interpret. So you are saying that you want to add HCl, but the question already specified they want to add H2SO4. So you mean like you want to do another step, like after reacting this, one more step on adding HCl, is it? Is that what you're trying to say? Oh, because of the sentence I say about separating is hard. Okay, so now if you have a layer of the CaSO4, then you add HCl, but the CaCO3 is hidden inside, what? That means your HCl cannot reach the CaCO3 inside. So how do you react the CaCO3 away? You understand? So that means your method doesn't work because the CaCO3 is stuck inside. So new HCl come in cannot react with the inside CaCO3. You understand? So even the HCl, when they first come in, they will first be exposed to your CaSO4 outside. So just now how I draw was, this is CaCO3, right? Then there is a layer of the CaSO4 outside. Yep, so if it's CaSO4, and then you suggest add HCl, there's no such reaction of acid plus salt. No reaction will occur. So HCl can't even reach the CaCO3 inside. So for Eaton's method, not possible. You now understand what I'm saying? Wait, then you are saying that for crystallization, isn't it for thermally unstable compound? True. Cause evaporation to dryness is for stable. True, correct. But the thing is that if your substance is stable to heat, you can also do crystallization. You cannot, okay, so that means how to say like, okay, so for substance stable to heat, you can only do evaporation. I shortcut, okay, evaporation to dryness. You can also do crystallization. For things that is unstable to heat, you can only do crystallization. Cannot do evaporation to dryness. Because if it's evaporation to dryness is like super hot until totally dry, then it will like decompose. That's why unstable to heat, you cannot evaporate. But if it's already stable to heat, be it fast method or slow method, since it's stable, it will forever won't decompose. That's why whichever method you use doesn't matter. But usually we will say stable to heat, you do evaporation, because in school lab, time is a concern. So we need it to be faster. So we do evaporation to dryness. But actually, out of two methods, if you got time, recommended to do crystallization, because crystallization is known to have higher purity of the salt form. It's more pure. That's why for evaporation versus crystallization, there is actually this like each of them have their own pros and cons. Yeah, so let me write it out. So it will be that like for evaporation to evaporation to dryness versus crystallization, advantage versus disadvantage. Yep, so for evaporation to dryness, the advantage is fast. But crystallization is slow. But there is no one best method on earth. If it is fast, that means it will be less pure. Okay, lower purity. Okay, let me write in proper English. Lower purity. But crystallization, although it's slow, but why do we still use this method? It's because it's higher purity. That's why for my method here, I mentioned crystallization is to be more pure. Okay, so Ethan understand now. I also addressed the part that you were asking. Okay, that's good. Any of you have any other questions that you would like to clarify? Okay, so then once you are done with this table over here, can you all click the raise hand button to let me know? Then I'll go through the answer. Just this page will do, okay? So once you're done, raise hand. If you can't raise hand, you can type in the chat to let me know that you are done. Then I'll go through the answer. By the way, just a reminder, okay, this one is just identifying which method to choose. So for the topic of salts, you need to really go and memorize the three procedures. That means these three methods, that means the precipitation, titration, and excess. Because in your school notes, there is the step-by-step, right? Step 1, do what? Step 2, do what? Step 3, do what? That one really must memorize. Because once they ask you a question, outline the procedure in preparing, maybe this time around preparing lead 2 chloride salt. So once they say outline the procedure, right? First step, of course, you need to identify which method first and what are the reagents. Then you have to really regurgitate out what you memorize from the notes. Means step 1, step 2, step 3, step 4. Yeah, so please continue to memorize from your school notes the step 1, step 2, step 3, step 4 for the 3 methods. Okay. And for the topic of salts, not only these 3 methods, there is also the qualitative analysis. Yeah, so some schools put it in the same chapter, some schools separate out. Yeah, so qualitative analysis, you also have to study it. But I won't be able to go through today due to time constraint because I want to go through like more topics. Yeah, so I can't do QA today also. But for QA, there are also ways to help you to remember like how to remember which one soluble in Excel, which one insoluble. So all these are only taught like during the actual lessons. Because today not enough time. And by the way, the rest of you, are y'all done? Still waiting for Elisa, a person called Comma, C, Gaby, Cal, Lishan, Shanice, and Tian Hong, are you done? Or are you still doing? Should I still wait for you a while? Or if you are not here, then maybe I just go through the answer. Because I cannot see you on webcam, so do not know whether you are present or absent. If you're still doing, maybe you want to tell me now so that I will like wait a while for you. If not, I'm going to show the answer. Okay, no response means should be not around. Okay, then I'll go through the answer now. Come, check your answers. Let me make bigger a bit. Okay, like that. Yep. So you check through your answer. Then if any of you got any of it wrong, can you tell me now so that I can go through with you the answer? So how any of it that you all got wrong? If you're not telling me anything, I really legit, I won't go through any of it. So if any of it you got wrong, you must really tell me so that I can go through with you. If not, I really won't go through. So how? Any of it that you want me to go through with you? So everything correct. Oh, nice. Okay, that's good, that's good. Okay, so, the FE one. Okay, sure. So for the reactant number 2, oh, sorry. I wrote here, but then I didn't put here. Oops, sorry. I realized this document very careless today. Sorry. Yeah. FE also can. Oops. Yeah, can, because I wrote over here. Yeah, so can. Any other questions? For Ethan's question, magnesium chloride. Why is magnesium chloride? What is magnesium chloride? Huh? Magnesium chloride? Which one? I don't understand which one is Ethan asking. I don't have magnesium chloride. The last one? Hey, wait. You mean your last one is magnesium chloride? Because my last one is barium sulfate. Oh, you mean like over here, is it like can the answer be magnesium chloride? Oh, okay. I was like thinking magnesium chloride. I don't see any magnesium or chloride. Like, how come magnesium chloride? Oh, okay. Over here, if you write magnesium chloride, then you see over here, to get sulfate, you have here. That means to get the barium, here must have barium, right? So you write magnesium then. Oh, you mean my last question and your last question is different? Oh, your last question is magnesium chloride. Oh, okay. Then in that case, wait, let me find where's my I got magnesium chloride here. Okay, sorry. Then you all check this one instead. Oops. Somehow I don't know how come my version and your version is different. Oh, sorry. Yeah, over here. Okay, you use this. Oops, sorry. Maybe sometimes copy and paste, and somehow it got shifted or something. This method, why is it not adding insoluble base to acid? Okay, so first is for it, as it is one that add excess the base one. Base is a metal oxide or metal hydroxide. So Ethan, yes, what it is adding insoluble base to acid. Yes, it is also adding carbonate to acid. It's okay. I make mistake too, so it's all right. Okay, so no more questions, right? If no more questions, I move on. Anything else? Yep, so if you got it correct, then you can continue to practice it to see whether like you can get the rest correct or not. Yeah. Okay, so I shall move on. So done for solves. Okay, so then next up, I will be moving on to Kahoot first before I go through the mole concept, because I know that for some schools, you all don't learn mole concept this year. So at least I can dismiss some of you all first. Okay, so anyways, before I start off with Kahoot, just wanted to share with you all that for this tuition center that I'm with now, it is called OVERMUGGED. There is group tuition available for next year, not this year. Now don't have tuition because too near to exam now. The best help we can give you is this lesson, the free tuition. Yep, so for those of you who are interested to sign up for tuition for Sec 4 next year, Year 4 next year, yep, so these are the locations. So if you like me to teach you, I will be at the Bukit Timah outlet. Okay, there are also other outlets available, including online also. Yep, so for the subjects that are available for your IP students will be Chem, Physics, EMath, and AMath. Yeah, so if you want like English tuition, we only have like the O-level kind. Yep, don't have the IP one. Yep. So then for timing wise, for weekdays, these are the timing, weekend, these are the timing. So for the timing wise, is actually also not really like very strictly, like have to be strictly stick to this timing. Yeah, because like for example, if you were to be having like we want to come over right after school kind, yeah, then maybe we can start at an earlier timing of like 3 p.m. to 5 p.m. That works too also. As long as the teacher and the students in the class, they are all agreeable. Yeah, the timing is not really fixed lah. Yeah. Okay, so then because I think some of y'all who attended my chemistry lesson last week, yeah, I think some of y'all have like some questions regarding the package here. So just to share with you that no matter you sign up for the early bird or trial package, all the lessons will only start in December. Yep. So for my classes, it will only start in December. So there is no tuition right now. So if you are interested to sign up for the tuition at OVERMUGGED, I'll recommend you to do it earlier, because the earlier you sign up, the earlier you will receive the exam kit. Yeah, so for those of you, I saw that you already signed up for this camp tuition for next year at OVERMUGGED website. I'll be sending you for Sec 3 now, for you to study the Sec 3 notes, for you to study for your camp exam by tomorrow the latest. Yeah, so after class, for those of you who have signed up with me, I will need to double check with you what are the topics, so that I can make sure that like topics you need have, or I think maybe I will just send. Okay, I see how first. Yeah, but anyways, as long as you sign up now, you'll get to receive the notes that you need to study for the exam now. So it's like I'm helping you for your this year's exam already. So once you sign up, I'll send it to you. So if any of you decide to sign up soon, yeah, once you sign up, you can also drop me a message to let me know that you have signed up. Then I can quickly send the notes to you. Okay. So anyways, my phone number is this, which is in the Zoom chat over here. Yeah, so it will be better that you drop me a text, then I can immediately send you, because the website I only check like once in a while. So if I didn't like check on time, then I scared like, you know, like delay the days that I send you the notes, then it will delay like your studying. Yeah, since your exam is like very near. So for the early bird, not only you receive the Sec 3 notes, you will also get to receive 3 curated notes. So it will be the full syllabus from Sec 3 to Sec 4 topics, which you will receive it when we meet in person, because it's a hard copy notes. Yeah, so you will be allowed to have 3 notes. One will be the subject you sign up. So maybe if you sign up for chemistry, one is chemistry, and then 2 other subjects you can choose. Like you want to choose math, you want to choose English, you want to choose like any other subject. As long as we have that subject notes, yeah, it will be given to you. So it will be worth from Sec 3 to Sec 4, and each booklet is worth at least $40. Yeah. And that for the lesson timing, I noticed that some of you were asking me like, what time slot am I teaching? Because you'll see a lot of time slot, right, on the website when you sign up. Yeah, so for the time slot now is that it will be based on what your majority chose. Then the lesson time will be at that timing. So that means like I don't really teach at a fixed timing, but mainly I teach from Tuesdays to Saturdays. Yeah, so as long as you pick a timing that is from Tuesday to Saturday, just don't Sunday and Monday. Yeah, it will be, for IP classes is usually taught by me from Tuesday to Saturdays. Yep. So then the lesson time it will be selected based on what the majority voted. Yeah. So that's why we say that early bird is that you have priority selection, because we chose the lesson time based on what you clicked. Yeah. So far, based on the sign up rates for Sec 3 IP Chem and IP Physics, it will so far I have quite some sign up from Nanyang Girls High. Yeah, so for the NYGH student, my lesson time will be Wednesday 7:30 and Friday 7:30. I will see which science to put on which day. Yeah, but so far that 2 time slot is like the popular timing chosen by NYGH students. Yeah, so the lesson will only start in December. So now for exam period, I'll just let you concentrate and study for your exam. Then after your exam, then I'll text you all again to discuss on like what lesson time, get a confirmation of the timing. Yeah, then tuition only start in December. Yeah, then for some of y'all have like travel plans in December. Then you are thinking, oh, maybe my travel plan is like 3 weeks, that kind. Then December maybe only got 4 weeks. Then you gone for 3 weeks. Then you only attend 1 lesson. So then for those of you who have travel plan, you have 2 options. One is, if you don't want to miss anything during the December lesson, you can watch the recorded lesson, or else another method is you attend from January onwards. That means because for the lesson fees in OVERMUGGED is paid on a monthly basis. Yeah, so that means if you are not able to attend December, the start date we can start for you in January. But once you start in January, you cannot say that I happy, maybe I attend January, February, then I want to stop for March. Then later April, May, I stop for June. Then July, August, I stop for September. You cannot like randomly stop. Yeah, because once you stop, it's considered a withdrawal already. Then if there are any student on the wait list of the class, then the next student will be coming in. Yeah, so generally for the classes for Bukit Timah outlet, the physical capacity, that means those who attend face-to-face, it will be kept up to 12 students. Yeah, so a class will be a mixture of both physical and online students. Yeah, so if any of you have travel plans, but you still want to sign up for either the early bird or the trial package, then you just need to indicate in the comments on the sign up page that maybe you prefer to start in Jan. Yeah, then we will take note that, okay, your start date will start in Jan. So that's why it is still okay to sign up now, even though you don't want to have tuition that soon. Okay, like you want to start only in Jan, you can still sign up now. Okay. Yeah, then of course we still have the normal intake. Like maybe after your WA1, then you realize, oh no, my result very bad. Then okay, I want tuition. I can, but the benefits will be less. Yeah, so you will only receive the notes of that subject that you're attending. So that means if you sign up for chem tuition, then you only receive chem notes. You won't get to receive like other subject notes. And also depends on the class. Like once the class is full, then yeah, you cannot join already. Yeah, I think some of my ex-students know, right? Like when previously you all were at the previous center together with me, my classes are like filled up very fast, then later cannot enter liao. Yeah, so all classes, likewise, like even at OVERMUGGED also, once the class is full, then you'll just be on the wait list. Yeah. So just to check, any of you have any other concerns or questions regarding the signing up of next year's tuition? So the tuition here are all for Sec 4 year 4, don't have Sec 3 tuition. Any questions? So seems like no question, right? Okay, then so if you are interested to sign up, here's the rates for IPE, and then you can scan the QR code, and then you select the subject that you want, then you sign up. Yeah, so once you sign up for my subject, drop me a text, okay? Then I can send you the notes immediately. So yeah, just more information. So it's a hybrid lesson. So there will be online and physical students in the same class. Like that. So if the venue not convenient for you, you can attend online. Okay, so now let's go over to Kahoot. So for the Kahoot, it will only be the top winner. That means only the person who win the first position, you'll get to receive the exam kit from me. Okay, so you try. So this one I made it quite fair. Like even if your chemistry is not good, you will still stand a chance to win. Because as long as you pay attention to what I've been going through just now so far, you should be able to answer. And you can check your notes, okay? So can you all log into Kahoot now? So even if your Kahoot placing, in between the Kahoot, you realize, your ranking is far from #1, but can you just continue to play the game, take it as an MCQ practice? Because after all, I'm still going to ask questions related to Ionic Equation and salts. So take it as an MCQ practice. So can you all log into the Kahoot now quickly so that I can start the game soon? Okay, so the rest of you who are not done, maybe I'm going to quickly note down the game pin because I about to click the start button soon. Okay, I count down from 5 seconds. 5, 4, 3, 2, 1. Let's go. So as mentioned, generally it would be questions that things that I've mentioned just now. So all the best. Obvious, right? Even give you the station name. So should be able to get it right. Okay, so continue on to the next question. So you see, it's doable even though your chemistry not good. It's okay one. This one I can check notes. We just went through, right? expecting more, correct? Okay, so for this question here, how to get the answer? This is zinc sulfate, right? So for zinc sulfate, by looking at the notes over here, okay, so for zinc sulfate, so you check sulfates, if it's zinc, it will be under here. So it will be soluble. So if it's soluble means it will be either spa or this one, soluble, right? Yep, so for zinc sulfate, it is not spa soluble. So it's not spa soluble. It will be at excess insoluble to acid. I told you already, it's always excess of the solid, so that it's easy for you to remove the solid by doing filtration. Okay? Yep, so that's why the answer, it will be at excess insoluble stuff to acid, not the other way around, not the green one, just like I emphasized. But this one, 50% chance to get it correct. Okay, so good, majority got it correct, but by a small margin. Okay, so why is it incorrect? The incorrect word is titrating. Because same thing, let's take a look at the notes again. So for barium, they say getting barium salt by titrating barium hydroxide. Okay, so for barium hydroxide, so if you look over here, for hydroxides, these are the only soluble one. Means barium hydroxide is insoluble. Insoluble, can you squeeze it into the burette or pipette for titration? You can't, right, if it's a solid powder. That's why you cannot do titration. Okay, so that's why the answer is false. So take note, okay, titration must always be the spa salts. Okay, titration is always spa, as shown in my notes over here. Yeah, over here. Okay, titration must always be spa. In this case, it's barium. Barium is not SPA. Okay, so that's why it's incorrect. Okay, then the next question. There are multiple correct answers. Any correct answer? Easier. Every topic clear to help you. Hey, by the way, just to check, this one is like, as long as you click one correct answer, you get the points already, is it? Or like you need to like click all, then can get like the points. Just wondering, like not quite sure for this kind of multi-select Kahoot. Like maybe can someone share with me? Like you click one correct already, is it? Or you need to click like all four? Hello. Like how is it? Oh, okay, thanks, Jason. Okay, so click one will do. Okay, can, that's good. So I wanted you all to get correct. Yeah, that's why I purposely have more correct answers. Okay, so the answer is no, is because for displacement reaction, although yeah, it's like you swap partner, but there is a need to have a change in state symbol. Did I mention it? I can't remember. Let me scroll back. Displacement reaction. Then over here, yeah, I did mention that displacement reaction must have a change in state. Yeah, your state symbol must be different. So for this question over here, you realize the state symbols are all the same. So cannot. So this is not a displacement reaction. So take note, okay, must have a change in state. This one I give you a bit more time. Okay, good. Because people, I told you before, right? This is one of the shortcuts. There are two shortcuts. One is neutralization of all the aqueous substances. So both are aqueous and then they are neutralization, right? So shortcut, directly just H plus and OH minus will do. Yeah, then the second shortcut was the precipitation reaction, right? Yeah, so must recognize like precipitation and neutralization, you can shortcut and get the answer. Don't need to like write out, cancel spectator, or that will be very slow. Yeah, so exam not enough time, must be, you know, like exam smart. This one is something lame. You know what the joke is, you might have come across it. It's not serious stuff, okay? Not bad. Quite a lot of y'all can catch my joke, okay? Okay, let's move on to the next one. This one just check the solubility table. Good. Yep. So this one just check the solubility table. Let me show it to you. It will be over here. This one. Yep. So only Ag and Pb is insoluble. Okay. So that's why you should choose Ag or Pb. Only Pb available here. So the answer is precipitation. Because first you check iron 3 carbonate got spa or not. It's not SP or A, right? This is I. So if this I, that means it will be non-spa. So non-spa next is you check, is it soluble or not? So in this case, it is actually iron carbonate. So you check, is iron carbonate soluble, or by right, you should have memorized by now because your exam is coming. So carbonates, all are insoluble except spa. So that means iron carbonate is insoluble. So once you reach here, insoluble. So the answer will be precipitation. Okay? Yeah, like that. I think this is the last question already. So this one by right should be able to score. I told you already, it's like so many, I purposely give a lot of correct answers some more. Yeah, and lesson don't start in October. Lessons start only in December. Okay, because I tell you the tuition is for Sec 4, not for Sec 3 tuition. Okay. Yep. Okay, so let's take a look at the results. Good job, Jizo. Good job. See who's the winner for today? Oh, congrats, Cheng-Yu. Okay, so yeah, I'll be sending the, that's Cheng-Yu, right? Just to confirm. Yeah, I'll be sending the prize to Cheng-Yu. I'll be giving you the exam kits. So maybe Cheng-Yu, can you stay back after class a short while for me to discuss with you regarding the sending of this exam kit to you? Yep, then yeah, after class we discuss more so that we don't need to delay everyone here. Okay, so yeah, that's all for the Kahoot. Okay, so for the lesson today, for those of you who don't do the mole concept for your Sec 3 end of year camp, right? Maybe I think I give you the answer key now first, so that for those of you who are leaving, you can leave first lor. Yeah, so if you don't need the mole, you can download the answer now. Actually, can everyone download it? Yeah, so that like, so that guarantee all of you have it. Yeah, then if any of you somehow you cannot scan the QR code successfully, can you let me know? Then I can send you the link instead. So how anyone cannot obtain the answer key? So all of you can get it, right? Okay, so then for those of you who don't need the mole concept for your Sec 3 end of year, you can leave already. Yep, so by the way, wait, before you leave, right, just to let you know that for the tuition, for the sign up, because I know that the today, now that I like share with you all, is that this early bird the deadline is like tonight. Yeah, so a bit rush. So only for chemistry students, yeah, and okay, for IP students like for you all here, if you want to sign up for tuition for chemistry IP tuition, yeah, so or the IP physics tuition, I extend the deadline a little bit over the weekend so that at least maybe you can like check with your parents first before you sign up, right? Because like it's a major decision. Yep, so I'll extend the deadline till coming Sunday, okay, for IP Chem and IP Physics. So if you want, you sign up by this weekend. Past this weekend, I'll be putting you under the trial package. So you won't receive the end of year exam notes. You also receive one less curated notes. Okay. Yep. So those of you who are who don't need to attend the mole concept, yep, you can leave already. That's all for today. Okay, so now I shall move on to the mole concept. Yep. So let's start from the beginning. Where's the mole first page? Yep, over here. Because the mole concept, a lot of like calculation and all, then I realized typing very tedious. I need to make like fraction and all. Then it's got a power of 23, then dm cube. Yeah, so I got a little bit lazy and I wrote it out instead. Yeah, so this is my handwriting, if y'all don't mind. Okay, so over here is the list of all the formulas as well as all the units. So take note that in chemistry, the unit for mass, it will be in gram. So for those of you who take physics, take note, it's not in kg, okay? Because physics is in kg, but chemistry is in gram. Then take note of the volume also. Normally we measure things like in cm cube or meter cube, but chemistry we measure it in dm cube. So need to know the conversion. So when you do the mole concept, generally the answer for number of moles tend to be less than 2. That means usually it's like decimal place, like 0 point something kind. Yeah, so if your answer is more than 2, then sometimes you can like double check your working and see like, is there anything wrong? Yeah, so the number of moles will only exceed 2 if the question give you in kg, which is seldom the case because usually chemistry we do it in test tube, in beakers, conical flasks. It will be just in grams. Yeah, it can't reach like kg to fit inside a conical flask or beaker. That's why usually the number is less than 2. So only if questions say in kg or in tons, then that kind is very heavy, right? Then yeah, it will exceed 2. But normal situation, it should not exceed 2. So this is one thing that you can check in your answer. Okay, then I take it that basic formula, you all should have learned it in school, so I don't want to go through each and single one by one, because like that not enough time to finish everything. Yep, so let's directly take a look at like how do we solve questions related to the mole. So most of the questions, it will always be this template. So you try to remember this template, okay? Because whenever you can't solve, you just use this template. High likely you can solve it, or else it's high likely even if you can't solve, you at least can get some method mark. Okay, so step 1 is you always, because this is a mole question, right? So that's why first step, it will be to go and find number of moles. So the most favorite formula that teacher like to test among these 10 formula, right? It will be formula number 1, which is mole is equals to mass over mR, and number 4, concentration is mole per dm cube. So take note that I would recommend that you should make it a good habit of always writing down, like instead of just writing number of mole equal, it will be good to indicate is number of mole of who. Because for the mole question, usually it's like got part A, part 1, part 2, then got part B, part 1, part 2, part C and all. So sometimes they might require you to use values from the previous part. So if you just write number of moles, then you don't know this number belongs to who. So it's always a good practice to always say that this is number of mole of which substance. So then when you do until the behind part, when you come back, at least you know, oh, okay, this is the number to start in. Yep, so that's why step 1, you either use formula 1 or 4. This is the most commonly used formula. If these 2 formula doesn't work, you then use the other formula that is available in the first page. Okay, so done with finding the mole, because this is the mole topic question. Yeah, then second step is you write a balanced chemical equation. Usually the question will give you, but if they never give you, then you just balance on your own. Then after done with step 2, you move on to step 3, which is called the mole ratio. So this is a template. Please memorize it, the purple color one. Yep, so for the purple color one, it will be, you always write down from this a presentation of answer. Although, yeah, sometimes your school didn't even ask you to write the first line, but this is like presentation of answer. So if your teacher is particular in presentation, I will recommend you to write in this first liner from the chemical equation, comma, number of mole of. So the first number over here is always the number you found from step 1. So example, if your step 1 is like maybe calcium carbonate, then you put in calcium carbonate for the first blank. The second blank over here, it will be what the question asks you. So maybe the question is asking you, how many moles of HCl reacted? Then you write HCl over here. Then next is, you write in the number. So it will be like, based on the chemical equation, is it like the in front number, like is it 2 calcium carbonate? Then is it like maybe 3 HCl? So write the number, 2 is to 3, for example. Then next is this number over here, it will be also from step 1. So it will be like whatever mole that you found, you put it in here, then you do your math accordingly. Or if it's 2:3, then you make sure that it's a 2:3 ratio. That's why I wrote here like that based on step 1. Okay, then the next step to do is you answer the question. So maybe question asking you, what is the concentration of the acid required? Then you use the concentration formula. Or if question asks, what is the volume of the carbon dioxide gas produced? Then you use the volume formula. Or question asking you percentage purity, you use percentage purity formula. So this is like the standard way of solving for most questions. Later, we will try out some practice question behind. Then you'll get to know whether like, like how come, you realize, this will always be used very often. Okay, so I shall move on. So generally, when to use this template, the hint is you look at the mark allocation. So usually the mole question is like not very nice kind. It's like if they ask you concentration, it's not like, immediately concentration equals then the formula. Usually not so good. Usually it will be like you need detour, you need to solve other things, then you can solve the one that you're interested. So usually it's a detour, so this is like the working. Okay, so let's try out an example over here. So sometimes they will ask you like number of particles inside, like number of like the ions inside or the number of atoms inside. So how do you solve such question? I will demo for the first one, you try the second one. Okay, so first is by looking at this one over here. How many moles of Ca2 plus ion? Take note, this is moles. I'm not asking number of ions. If I ask number of ions without the word mole, in number of ions, you will have to use this one, the number of ions. So particles here can be number of atoms, number of molecules, or number of ions. Okay, so number of ions, then you need to use this Avogadro's constant. But now I'm not asking you number of ions. I'm asking you number of moles of ions. As seen over here. So that's why it will be moles of ions. So what you do is you use the mole ratio. So this time around inside here, I only got 1 Ca. So I write 1. Then remember to always times the number in front. So times 1. So the final answer will be 1. I demo one more time to you. How many moles of CO32 minus ions are there? Over here, I can tell that it's only one set. Because don't have like bracket 2 or 3. So if only one set, I write 1. Then remember to always times back what is given in the question. That's why the final answer will be still 1. Next, number of mole of ions. What kind of ions are present? Over here, there is a Ca2 plus ion and CO32 minus ion. So there are 2 ions. So that's why I write 2, which you can see over here. There, how many moles of ions? There 2. So actually 2 is the answer. But if I want to do like the manual way like just now, I'll count. There are 2. Then remember to times the number in front. So that's why the answer is 1. Then next, number of moles of O atoms. So over here, I have 3 oxygen. So I'll put in number 3. Then remember to times the number in front, times 1. That's why the answer will be 3 moles. By right, you add your unit, but a bit no space. So never mind. Like that. Okay, so right now, your turn. Can you give it a try to do the one on the right? Thanks, Cheng Yu. Oops, so careless. Sorry. 2 times 1 is 2. Thanks. Alamak. So obvious it's a mistake. Okay, so can you do the one that is on the right side here? Then I'll go through in a while. Once you are done with the H3PO4, all of them here, this one. Once you are done, can you click the raise hand button to let me know? Then I'll go through the answer. So once you are done for this part that I circled, remember to click the raise hand button. By the way, for students who are very strong in chemistry, if you find the lesson pace a bit slow, because today I need to cater to all levels of students. Yep, so if you find that lesson a bit slow, same thing, this topic, every topic I will have like homework section. So you want, if you can multitask, you can try and do it while waiting for the rest to complete this part here. Yeah. So just to check for Tian Hong, Shanice, Lin Xuan, Cal, someone whose name is Happy Face, and someone who is a comma. Are you all done? Or are you still doing? If still doing, maybe can you let me know that I'm on hold first? If not, I'm going to flash the answer. Okay, so I shall go through the answer now because I didn't receive any response to tell me to wait, right? Okay, that means done, right? Okay, come. Then let's go through the answer. So the answer for the right side, it will be, let me write it down. It will be 1.5 mole. Oh no, wait, hold on. Oh yeah, okay, then and then 0.5 mole, 2 mole, and 2 mole. So how any of you need me to go through any of it here? Any of it that you got wrong? Because if you don't tell me, I really won't be going through, then I move on now. So how any of it that you want me to go through? So, okay, nice. Good that you all get it right. That's good, that's good. Okay, so let's move on to the next part. So over here, there is this thing called volume ratio. So is that like, if question were to give you 100 cm³ of N2 gas, there is actually a shortcut. It means you don't need to go and like same thing again. Don't need to do this whole thing again. First step, find mole. Second step, equation. Third step, mole ratio. You don't need to go through the tedious way. The reason is because only for gas, if you see the formula, right, it will be actually volume over 24. So that means no matter which substance you choose, it is always divided by 24. So can you see that the number of mole is directly proportional to the volume? Can you see? Because the denominator is always the same. That's why it's directly proportional. As compared to if the question gives you in gram, then it's different now. Okay? So if the question gives you in volume, it's like, if it's like one, like, you know, the balance equation, if the number in front is 1, they say 10 cm³. Then maybe another substance, the in front number, like, you know, like write chemical equation 1 plus like 2 something, you get 3 something, for example. Yep. So if 1, they say is 10 cm³, you can safely say that 2 means 20 cm³ and 3 is 30 cm³, because they are directly proportional. But for maths cannot. If the question says this one, example, maybe, okay, I use real equation, easier to understand. Maybe like that. Yeah, so if I say that this one is 10 gram, okay, I use a nice number, 20 gram cost 2. You cannot say that this is 10 gram and this is 20 gram based on the number in front. Cannot. You cannot base on the number in front to say the gram is like directly proportional. Because if you look over here, the denominator will change. Because it is based on the number in the periodic table. Yeah, because like H, the periodic table number is 1, oxygen is like 16. Yeah, so the denominator is different. So the number of mole and the mass are not directly proportional. So you cannot say that 2 mole means 20, then 1 mole means 10. No, they are not directly proportional. That's why if they give you in gram, you still need to use back this one, the 4 steps over here for gram. You have to use back the traditional long-winded calculation. Only for volume, you can shortcut, which I call it as volume ratio. So let me demo it to you. So in this case, they say that there is 100 cm³ of nitrogen gas. So if this is 100 cm³, this is 1 unit, right? That means 1 unit is 100 cm³. So now they ask you for H2. H2 is 3 units. Then you do your simple math. So 1 unit is 100. 3 unit will be 300. Yep, like that. Okay. Okay, then next is NH3 is 2 units. Then do your simple math again. 1 unit is 100. 2 unit will be 200. Yeah, so you see, don't need to use mole formula at all. You just directly, like, ratio will do. Then next is volume of reactant. Reactant is 1 plus 3. 1 plus 3, that means 400 cm³. Then product is 2. That's why it's 200 cm³. Yeah, done. So it's very straightforward. So actually when only for gas, there is this shortcut. So can save time for your exam. Of course, if you want to use back the step 1 to 4 can also, just that it will be like very slow Your course got shortcut. Okay. So now same thing, your turn. Yep. So can you finish this up? Then likewise, once you are done, can you click the raise hand button to let me know? Then once you're finished, I'll go through the answer. To be quite fast, just have to be careful. Be careful. Once you have finished, click the raise hand button. Okay, so I shall go through the answer now. For Joshua, Tian Hong, and the smiley face person, are you all done? Shall I go through the answer? Okay, so the answer will be 10, 20, 30, 20. Ta-da! Did any of you got any of it wrong? Need me to go through? Because if you are not asking me to go through, I really will move on. So how, anyone need me to go through? Anyone? Or need me to go through all of them? So, oh, okay, right? Okay, then I really move on. That's good. Good that you got it right. Yeah, because 20 cm cube is 2 units. So 2 unit is 20. That's why 1 unit will be 10 and so on. Okay, so let's move on to the next question. Okay, so for the next part over here on limiting reactants, wait, let me see whether before I start with limiting reactants, can we try out some practice question first? Yeah, I think we try out some practice. Let me see, I think can do. Okay, we try out this page first before I start on limiting reactant, because that's another like new section. Okay, can y'all flip to this page now? Okay, so for this question here, yeah, so for worksheet question, there will be, you will notice that there are another category of question which is called water of crystallization. Water of crystallization still make use of all the formulas that we learned just now and all the like mole ratio stuff. Yep, so let me demo to you a simple one. So this is level 1. Then once we conquer this, we'll go to a more chim water of crystallization question, which is like level 2 over here. Okay, so for water of crystallization, what does it mean? It means that the compound inside got this water of crystallization. So that means like for copper 2 sulfate, usually when it's moist, it means like got this water of crystallization, it will be like blue color. But then if it is totally dry, right, don't have this water of crystallization, that means if it's purely just CuSO4 dry, then it will be like white color. Yeah, that's why usually for copper 2 sulfate is one of the reactant that we can test out whether the gas is dry or not. Yeah. Okay, so they say that formula of hydrated, that means got water, is this. So N, it will be a number. It can be 1, 2, 3, 4, or 5. So they said that when hydrated copper 2 sulfate is heated, anhydrous copper 2 sulfate, which is this, anhydrous. Okay, so hydrated means got water. Anhydrous means opposite. So that's why no water is formed and water vapor is given off as shown here. So they said that 2 grams of hydrated copper 2 sulfate was heated until no further loss in mass was recorded. And by the end of the reaction, the mass of this anhydrous copper 2 sulfate is this. Okay, so maybe let's label in the numbers first. So this one is the hydrated one. So the hydrated one here is 2 grams. Then the dry one is 1.28 grams. So the difference in gram actually goes to the water. Can you tell? Because 2 grams is made of 1.28 plus the remaining gram. Yeah. So for part A, state which instrument was used to determine the mass of solid. So how anyone can tell me the answer? Which apparatus do you use to measure mass in gram? So what's the answer? What apparatus? Correct. Thank you, Ethan. Yep. So it's the electronic balance. Yep, write it in. Then B part 1, calculate the number of moles of anhydrous copper 2 sulfate form. So anhydrous means the no water one. That means what they are asking you will be this one over here. So you can calculate, right? Can you do it on your own? It's very simple. Yeah, so anhydrous is the one that is dry. So it's very easy. Just one step can get answer now. Yep, do it now, do it now. Once you are done, once you got the answer for B part 1, can you click the raise hand button? Then once you are done, I will review the answer. If you are fast, you know how to do part 2, you can move on. But once you finish part 1, at least raise hand first, can, so that I can review the answer to you. Then you press calculator. How, done with part 1? If done, raise hand. Okay, so I think I shall review the answer now. So the answer will be this. Do you all remember to include the unit? Can you add it in? Anyone can't get the answer? Need me to demo to you how to get? This is just the mass over MR. You all know what number to start in, right? I move on. Okay, so moving on to part 2. Calculate the number of moles of water vapor released. Okay, so you know how many grams is the water vapor, right? Because just now we said this whole thing is 2 grams. So 2 equals to 1.28 plus water. So at least the first step, you go and find out what's the gram for water. Then once you found the mass of the water, you should be able to tell the number of moles, right? So because there is a formula linking mass and mole, isn't it? So from mass, how to find mole? Then likewise, once you are done with part 2, raise hand, then I shall review the answer. Once you're done with part 2, raise hand. Then for those of you who are fast, if you know how to do part 3, you can go ahead. So for Chengyu, Shannon, Shanice, and ZL, are you all done for part 2? Okay, so the answer for part 2 will be 0.04 moles. Anyone got it wrong? Do you all remember to include the unit? Anyone need me to go through? So I'll be correct. Oh, nice. That's good. That's good. Getting correct is good. Okay, so then next step is calculate the value of N. So since you know that you have like the 0.04 mole of water vapor, right? So next to find the number of mole of N is, it is always, so that means this N is not just 0.04 because the N is a ratio with the copper sulfate. So it's always 1 copper sulfate is to how many water. So that means you need to go and find out what's the number of moles of copper sulfate. So now looking back at the previous few part, what is the number of mole of copper sulfate? You all calculated just now, right? Can I have an answer? What's the number of mole of copper sulfate? Hello, I'm asking a question. Can I have a response? You calculated previously, right? The number of moles of this copper sulfate. Yep, thank you, Tara. Yep, is 0.08. Sorry, 0.008, Tara, be careful. Yep, thank you, ZL. Yep, so in this case, yeah, you now need to change it to 1 is to something. Also, now you know the ratio is this is to this. Can you change it to 1 is to something? So that's how you find the N. Okay, so take note, the N is not just the number of mole itself. It has to be always in terms of 1 copper sulfate is to N. Yep, so now we're going to find out if copper sulfate is 1, N will be how much? So Ethan say 5. Yes, correct. So it's 1 is to 5. Okay, so the answer will be 5. Done. So just write a final statement that N is equals to 5. Okay, yep, like that. Okay, so just to let you know, okay, so try to remember that whenever it's a water of crystallization question, can you remember it's a standard 3 steps. Usually number 1 is you go and find the number of moles of the anhydrous first. That's step 1. Then number 2, you go and step 2, number of moles of water vapor. Then you do the ratio of 1 is to something. Can? So take note, usually that means for water of crystallization questions, sometimes they're not so nice. Wow, right now, part 1, part 2, part 3, they are hand-holding you, for this question. So that's why I say this is just level 1 question, it's easy. But sometimes it might not be so nice, like the next question, it's just an MCQ. So if it's MCQ, there is no part 1, part 2, part 3. So you need to know how to approach water of crystallization question, which is these 3 steps. Okay, so right now, can you apply these 3 steps into this question now? Yeah, can you do it now? Then once you are done, likewise, once you are done, can you click the raise hand button to let me know? Then I'll review the answer. Yeah, you do question number 2 now. Once you are done, raise hand. For those who raise hand already, since you're already done with question 2, you want to double check with the answer key. Yes, you can see whether do you get it correct or not. Yeah, then if you got it wrong, you read through the working first. If you don't understand, then later you can alert me, then I'll go through and explain to you. Yep, so once you are done with the MCQ question number 2, raise hand, then check your answer using the answer key. So remember, always follow these 3 steps. If you follow these 3 steps, you should be able to get the correct answer. Okay, just to check for Elisa, Cal, M, Lin Xuan, Prasanna, ZL, are you all done with the MCQ question number 2? This one here. Okay, use the 3 steps. Okay, so the correct answer, I think you all saw the answer key, right? The answer is C. Anyone don't understand my explanation, like my working? Do you all need me to explain? Anyone need me to explain? So, okay, right? Okay, then I move on. Yeah, so just take note, whenever it's water or crystallization, remember to just follow these 3 steps. Once you follow these 3 steps, usually you can get the answer. Okay, so this is the technique for water or crystallization. So hope it appears in your exam, then you can score. Yep, okay, so then is there any more question? Okay, come, let's give it a try on this kind of question, percentage U and percentage mass. So percentage U, you have to use the formula from the first page, but we'll do this question together. The question says, when reduction of hematite to iron occurs in the blast furnace is just a very hot machine. They're very, very hot. Yep. Then they say carbon monoxide reduce the iron 3 oxide in hematite to iron. Okay. Hematite over here is referring to the rock that, those rock that you try to dig from the ground. Yeah. Then inside it will contain iron and other impurities. So this rock, if you expose it to carbon monoxide, then the iron 3 oxide will form iron, then you can use the pure iron to make whatever products. Yeah. So assuming that 80 kg of iron 3 oxide was reacted and 49 kg of pure iron was obtained, calculate the percentage yield of this reaction. So they are saying that if they manage to get 49 kg of pure iron, this is how good is this experiment? Is it just you only managed to obtain 43% of it, or are you able to obtain up to 87.5%? Okay, so whenever you see this kind of question, then wow, they only give 2 mass. Then this mass is you also not very sure how to go about doing it. So what you need to do is, whenever unsure, right, always follow this answering technique. Yep. So always use this template whenever unsure, because except water or crystallization question, the rest of the question, mostly they tend to use this template. Yeah, so step 1, let's find out number of mole first, then chemical equation. Let's write it in. So find number of mole first. So whose number or mole can we find? So in this case, because they're asking for percentage yield, so do you use 49 or 80? So if you refer back to my notes first page, wait, where's my bar? Cannot see. Yeah, so if you refer back to the first page of my notes, right, for the percentage purity over here, usually is the mass of the pure substance over total mass. So the mass of the pure substance is given, right? Because they told you is 49 kg of pure iron. So that means actually the 49, you should put it into the numerator. Then be careful. The mass, it must be in grams. So for this question, they gave it in kg. So later your 49 kg, you must put it as gram. Okay, so that's why that 49 kg will be your numerator, because that's the pure one. Yeah, so since the numerator is 49 kg, that means you should use this value here to do your step 1. So what is step 1 again? Step 1 is find number of mole using formula 1 or 4. Since they give you mass, that means you should use formula number 1, because formula number 1 got mass. But formula number 4 don't have mass. Okay, so let's use formula number 1 now. Remember to change the mass to gram. Yep, so can you do that now? So step 1, find number of mole. You do it now. I wait for you. Number of moles of the iron 2 oxide, which is Fe2O3. Yep, do it now. You press your calculator. Okay, then after you're done with step 1, then moving on to the next step. So in my notes, I mentioned that step 2, it will be to write the balanced chemical equation, which the question will give you. Yeah, so we follow the question instruction. What the question give me? The question say that I have the carbon monoxide, so I write down CO, reduce this, that means it reacts with this, Fe2O3, to form iron. Yep, then after that, what is left? So I haven't write C, I write C. I haven't write O. C and O usually form CO2 law. Yeah, because you can't form CO3 lah. CO3 is like ion. Yeah, you cannot exist. Chemical equation don't have ions, okay? Yeah, so CO2 is the best answer. Yeah, then now can you balance the equation? So that's step 2. Then after you balance the equation, same thing, we follow the template. What is step 3? Step 3 is this. Yeah, from the chemical equation over here. Okay, so now I'm going to just write it in over here so that I don't need to copy it again. Yeah, so you just copy down from the chemical equation, comma, then write down this. Yeah, so this time around, it will be number of moles of what thing? It will be number of moles of what you found in step 1, right? So step 1 is Fe2O3. Yep, so can you copy it down? From the chemical equation, comma, number of moles of Fe2O3 versus this one I said, right, is based on the question. What is the question asking you? The question is asking you about the pure iron. How pure is it, right? So how much do you obtain the pure iron? So this one you write Fe because the question is asking you about iron. Yep, so then after you balance the equation, I write in number. So what's the number over here in front of the Fe2O3? As well as what is the number in front of Fe? You write it over here. Then next is you have calculated, right, over here, the number of moles of Fe2O3. So this will be the answer over here. They do mole ratio to find out what's the number of mole of Fe. Then after you found the mole ratio, number of mole of Fe, then you solve the question accordingly. So this time round, they are asking you for the percentage purity, right? Yep, percentage U, right? Yep, so that's why now you just go and calculate what's the percentage U. Yep, so for the percentage U, you have to be in terms of gram, right? But here is in terms of mole, right? Your answer here is in terms of mole. So that's why first is at least go and find out what is the mass. So theoretical U is always in gram, it's always mass. So theoretical means I use the mole calculation to solve. That's called theoretical. Okay, so for theoretical wise, since I have this number of mole, yeah, you go and take this number by right, just to do a quick check. Actually, when you reach here, the number of mole, if you go and take mole times the MR, you should get the answer 56. So you check whether 56 kg. Or else, if it is in gram, then it's 56,000. So you calculate, see whether can you hit 56. If you didn't hit 56, means somewhere you have careless mistake. Yep. So then in the end, what's the percentage you? You check the formula on the first page. Yep. So on the first page, the formulas, just like I went through with you, right? It is the pure mass. Pure mass, the question gave you, it was 49 kg, right? Yeah, then over, theoretically, if I can get all the pure substance out, if I can get successfully 100% efficiency, right, I should get 56 kg. Yeah, since it's percentage, must always times 100. Yeah, then you go and calculate, and then you choose your answer. Done. So once you have finished this MCQ question, once you have gotten an answer like option A, B, C, or D, can you click the raise hand button? Then likewise, after you click the raise hand button, can you go and check the answer key? Do you get the correct answer? All right, should be correct. Like if you can get 56, your final answer should be correct. It's only if you didn't get 56, then maybe if you can't spot your own careless mistake, then maybe you want to like double check with the answer key. Okay, or maybe to make it convenient for you, I shall flash it on the screen soon. Yeah, but anyways, once you are done and for this MCQ, you manage to get an answer, can you click the raise hand button to let me know? So once you solve this question number 3, percentage U, raise hand. Then for those of you who are fast, you can move on to the next MCQ, question number 4. So once you're done with 3, raise hand, check using the answer key, then do question 4. I repeat, your instruction is to complete question number 3. You check the answer key for your answer. If done, you raise hand, then move on to question 4, meanwhile waiting for the rest to finish. So Elisa, Cal, Shanice, and ZL, are you all done for question 3? This one, the one that is on the screen here. Okay, okay, so let's move on to question number 4. Means question number 3, you can just check the answer key for the answer. Okay, all the working are here. Just to check, anyone need me to go through like why the answer is like that? Anyone need me to go through any of the steps here? So everyone is all right, right? Okay, so if all right, then good, that's good. Yep, so I will move on to the next question. Okay, so for the next question, it will be the percentage mass. Yep, so for this question, how do you solve it? So in this question here, this one is a slightly different kind of question. That means like it's not the standard like template, like you know, like water or crystallization got template. Then question 3 also got template, right? So question 4 don't have template. Question 4 is that you need to, how to say, you use your English understanding of a sentence, then you solve accordingly. So that means like they are asking you what's the percentage mass of carbon in this gram of calcium carbonate. Okay, so now you go and find out how much carbon are there in calcium carbonate first. Yep, so in terms of mass, so carbon, the mass, if you check periodic table, it is 12, correct? So first step, I will go by, because they're asking you how much mass of carbon inside this. So I'm going to find out how much carbon are there inside calcium carbonate. So I'll write down Ca plus C plus O3. So it's CaCO3. Then times 100. Yeah, so I'm trying to find out the percentage. That means how in the entire calcium carbonate, how much is calcium? Okay, so that's the first step. Okay, then after you found the percentage, then next is they are asking you that it has to be in the 16.8 gram. So if you know how many percent it is, then you just take 16.8 times whatever percent that you have over here, times whatever percent you have over here. Okay, yeah, then done. So the amount of gram will be the answer. Okay, so this answer you just transfer down. Because first you go and find the, based on question, how much carbon are there in calcium carbonate? So I go and calculate carbon in calcium carbonate. Then now they want to be in terms of 16.8 gram. So out of the 16.8 gram, how many percent is carbon? I go and multiply, that will be the gram. Okay, so once you have completed question number 4, can you raise hand? Then I'll review the answer, or you can check the answer key also can. So once you finish question number 4, raise hand. Anyone need me to repeat? Do you understand what I'm saying? So Ethan, Norman, and Shannon done. So I review the correct answer. So the correct answer will be 2.016. So 2.016, the answer is C for 2SF value. Yeah, like that. Done. Okay, so then let me now go back to the limiting reagent section. Yep, so just now I skipped, right? Yep, over here, last page for today. So for limiting reactant. So limiting reactant generally is that one you add in excess, then one not enough. So in such a situation, take note, okay, whenever you do the mole calculation, always use the limiting reactant number in calculating the mole. Yeah. Okay, so then now, yeah, that's why I say follow the lower amount for calculation of the mole. Okay, so now how do we even identify is a limiting reactant? So for this question here, they have this equation and they say that 100 cm³ of N2 gas and 600 cm³ of H2 gas is given. Okay, so same thing. As long as they are all gas, you can do shortcut, right? By doing the volume ratio. Yep, so in this case, you go and calculate also. Maybe you just randomly choose either one. You can choose N2 or H2 also can, up to you. So maybe I choose N2. So N2 is 100 cm³. So this is saying that 1 unit is 100 cm³. So how much H2 do I need? H2 is 3 units. So that means 3 units by right. 1 is 100. 3 will be 300. So that means I need 300 cm³ of H2. But how much am I given? I'm given 600. That means I'm given too much. That's why H2 will be the excess reagent, and hence N2 will be the limiting reactant. Yeah, so usually how to identify limiting is you just randomly sub in one number. Then you see in the end which one enough, which one is not enough, which one is just nice. Yeah. Okay, so in this case, what's the volume of N2 that reacted? It will be all because N2 not enough. That's why the answer is 100 cm³. Then how much H2 reacted? By right, 1:3. So by right, it should be 300. How much NH3 produced? 2 units. So 2 units will be 200. So far can follow, right? Okay, then next is what is the volume of the product? So product is the behind. So behind is NH3, which is 200. What's the volume of unreacted reactants? It will be only the excess one that is unreacted. So I'm given 600, but I only need 300. I only use 300. That's why it will be excess of 300. Okay, then next one, total volume of gas at the end of the reaction. Sorry, we cannot see because it's a bit too below our arrow up over here. So for total volume at the end of the reaction, take note, it will be at the end. It will be the product, right? You must remember to include the excess leftover. Yep, so the excess unreacted must include them also. Yep, so in this case, the product that we have just now, we said is 200 for the product, right? And how much didn't react? It is 200 that didn't react. That's why the product, it will be 400 cm³. Yeah, like that. Done. Okay, so now once you are done copying, if no questions, can you finish up the bottom two? Yep, then once we go through the answer, then yeah, then we'll dismiss. So if any of you don't understand any parts for this first example, please let me know now, then I can repeat it for you. If you're all right, can you finish up this whole page? Then once you have finished this whole page, you raise hand, we go through the answer, and done. That's all for today. So take note, over here is just identify which ones are limiting. Then whenever there is any mole question calculation, right, remember to always follow the limiting value, okay? Like that means like got 100 versus 600. Since 100 is limiting, all calculations should always based on 100. Yeah, don't use the 600. For those of you who are done with this whole page, after you raise hand, can you like check through your answer using the answer key since I already given you the answer key? You look through, then you see which one wrong. The one that you got wrong, maybe can you tell me in the chat now? Then I can go through it with you. So I repeat, once you have finished, you check your answer. Yeah, then after you check your answer already, then you let me know which question to go through, okay? So once you finish, you raise hand, you check your answer, then let me know which question to go through if you got any of it wrong. So the instruction is in red here. By right, you should be doing quite fast because there is no need to use any formula from the first page. Everything is just ratio. Like 1 unit is how much and stuff. Okay, so Prasanna is asking, can you use the same formula if ammonia produced is equals? Cannot. Because this direct ratio thing, this is called volume ratio. Volume ratio is only applicable for gas. Yeah, so if it's other substance, cannot. You need to, if it's other state symbol, right, then you really need to do the manual way, which is the template, the step 1, step 2, step 3, step 4, which is on this page here. This one. Yeah, so as long as it is not everything gas, you have to use this ratio to find the ratio and the number. Yeah, so only gas got shortcut. No problem. So M, Shanice, and XT done. So how the rest of you, any of it that you want me to go through now? If not, I'll end the session already. So how any of it that y'all got wrong want me to go through? Yes, XT? Yes, what's your question? You sent already. Oh, on top. Oh, sorry, I missed your question. Okay. You are asking for this question here, right? This one, right? This example here. You're saying, isn't the unreacted product 300? Yeah, correct, 300. Oh, I careless. Thank you, XT. Oh, yeah. So careless again. Sorry, today I'm very careless. Okay, so today, yeah, so this one over here is unreacted. Yep, unreacted, it should be, alamak, 300. Sorry, thanks for highlighting. Yep, so the answer should become 500. People, can you amend it? Oops, sorry. Any other question? So that's all right. Okay, nice. Yep. So then, for the rest of the questions in this worksheet, all chapters got homework, right? I'll recommend you to finish them. Yeah, then you just check through using the answer key. Then if any of you not sure whether like why the answer is like that, yeah, you can feel free to contact me at my phone number. Just take photo of that question, then I'll answer you. Okay, yeah. So you all have my number, right? Which is in the Zoom chat. Yeah. So here. So I shall end of the lesson here. So wishing all of you all the best for your Sec 3 end of year exam. So for those of you who are interested to sign up for Sec 4 tuition, remember to do so by weekend, because the early bird package is only until coming Sunday. But of course, you can wait until like after your EOY result is out, then you then sign up for the trial package also can. Yep, so then, yep, so that's all for today. That's all. Yep, y'all can go already. Bye-bye. Yes, for Chengyu, is Chengyu still around? Yep. Okay, let me maybe answer Prasanna's question first. You're asking about what's the difference between percentage purity and percentage yield. Percentage purity is about like maybe I dig out this stone, how pure is it? That means like how much is pure iron versus the impurity. Percentage yield is like maybe when I try to dig out, maybe I do the experiment, I can only get 50 grams, but maybe I do the mole calculation, I should be getting 100 grams. That means what you do in your experiment is not very efficient. So my experiment only like 50% efficient. So that is called percentage yield. So Prasanna can understand? Okay, any other questions, anyone? No more? Then I shall stop the recording. Yep, so yep, all of you, yep, all the best for your